Hello and welcome to this video on reduction. So what do we do in reduction? Well, we increase our carbon-hydrogen bonds, but at the same time, we will be decreasing carbon-oxygen bonds. And the reagents we use to reduce with are sodium, borohydride, and lithium aluminum hydride. Lithium aluminum hydride is stronger than sodium borohydride, but in this video I will be focusing on sodium borohydride. So what can sodium borohydride reduce? Well, it can reduce ketones, it can reduce aldehydes, and it can reduce acyl chlorides. So what do these things look like? Well, ketones look like this. Aldehydes look like this. And acyl chlorides look like this. That was worse. There we go. So let's look at the structure of sodium borohydride before I do an example. So sodium borohydride, let's just remove the cation, which is the sodium. We have a boron surrounded by 4 hydrogen. That gives this boron a negative formal charge, but this is where formal charges are misleading to people. So formal charges equals misleading, because hydrogen is actually more electronegative than boron. One may think that boron's more electronegative because of this negative formal charge, but that's not the case. Hydrogen is more electronegative, so we have this small dipole here, giving this hydrogen a delta minus, while this boron has a delta plus. That's just something that's important to go over. Some people might get confused on a test question when it says, what's more electronegative, boron or hydrogen? Well, hydrogen is more electronegative, but very slightly. I believe it's 2.1 for hydrogen and 2.0 for boron. I could be wrong there, but I do not believe I am. Now let's do an example. All right, let's do an example here. So let's just take a ketone and react it with sodium borohydride and aqueous HCl, which is represented by this. And this part is important and it'll make a lot more sense when I go through the mechanism. So the first thing that happens is our hydride is going to attack this carbon, this electrophilic carbon, this big delta plus. This oxygen is delta minus. Anyways, so we have our boron with 4 hydrogens. One of these hydrides are going to attack this carbon right here. And when I say hydride, I mean both of the electrons in this bond are coming with this hydrogen. That's why it's called a hydride. So really, if you want to do a shortcut, you could just say H minus is attacking that carbon. So this hydride will attack this carbon and it will push up these electrons. It will break this pi bond. If we didn't break that pi bond, we would have 1, 2, 3, 4, 5 bonds, and we can't have that. So now we have something that looks like this, an O minus. Our hydride from the sodium borohydride attached right here. There's our hydrogen from the sodium borohydride. Now we have this O minus, and we need to protonate that. That will be protonated by the HCl H2O part. So first step was the reduction. Second part is protonating that oxygen. So we can just write plus, I don't know, we could do HCl if you want. You could just write HCl. Takes that proton, kicks off that chlorine, or you could say water protonates that oxygen, or you could say a hydronium, will protonate that oxygen. But the main part of this HCl H2O is to create the alcohol. So I'm just going to write plus H plus to make our alcohol. So we would get a secondary alcohol from this reaction. That would be your answer. Let's do some more examples. Okay, in this video, I want to do an aldehyde example. So, aldehyde. So let's look at something that looks like this. So we're going to reduce this aldehyde with sodium borohydride, and then we are going to protonate that oxygen, that O minus, with HCl and H2O. So the first thing that happens is our hydride from sodium borohydride is going to attach to this carbon. So here's our boron, our hydrogens. One of these hydrogens is going to attach right here, and that's going to break our pi bond. So this whole part right here is attaching. This H minus, if you want to look at it like that, is attaching to this carbon. That pi bond's being broken, and we are going to get something that looks like this. O minus. And then our HCl H2O is going to protonate this, so I'll just write water, or actually I could write even hydronium. We'll protonate that oxygen to give us something that looks like this. Now you might see an answer be written like this. Keep in mind this is the same thing because we have 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5, 6 carbons. These two H's are right here. And there's our primary oxygen, our primary alcohol. So we went from an aldehyde to a primary alcohol. And that would be your answer for this problem. I'm going to do one more so you can see what is actually attaching so it can be really engraved into your mind. Okay, let's test our knowledge and see if we know what we're doing. So let's take a regular old ketone and react it with sodium borohydride, and we will react it with a DCl D2O, and D is just an isotope of hydrogen, which is deuterium. This will help you know where you see things are attaching. So the first thing we do in this reaction is add our sodium borohydride. One of these hydrogens is going to attack this carbon. So this whole thing, this H minus, if you want to look at it like that, with these two electrons, will attack right there. And that will shift these electrons from the pi bond up. So we'll get something that looks like this. With, oops, did not mean to do that. Something that looks like this. And then we do our aqueous workup with DCl D2O. So I'll just write D plus. That will attach to this oxygen. So we'll have something that looks like this, OD, with this hydride attached right here if you want to actually see it. So what's protonating that oxygen is this step. What's adding to this carbon is this step. So we could have done something completely different where we had oxygen reacting with sodium BH or BD4 and HCl H2O to get something that looks like this, with our deuterium going off this carbon. But for this example, our deuterium protonated the oxygen right here. So that really does it for this video on reduction. I hoped everything was clear. If you have any questions, please comment down below. And thank you for watching.